Welcome to day 2 of Google Cloud Next. I hope you're all having as much fun as I am. Well, in the era of AI and agents, multi-cloud networking is more critical than ever before. And we have an exciting session planned for you today. My name is Himanshu Mehra. I'll be joined by my colleague, Mahesh, and our esteemed customer, Nate, who agreed to support us today. We are very happy for his support. Cross-cloud network continues to grow. Thanks to all of you, our customers, we have tremendous adoption across the different components. In this session, we'll focus on Pillar 1 and talk to you about the best practices in building and the latest and greatest in building multi-cloud networking and supporting your distributed applications there. Now, there are multiple trends which are driving the adoption and distribution of building distributed applications. We talked about a lot of them last couple of years, but I think agentic AI, with the taking off of agentic AI, developers are really looking to connect across different MCP tools and servers, or connect across different agents, and creating agentic workflows, and you probably have seen a lot of them this week, without regard to where that infrastructure might be, without regard to any infrastructure constraints. Our goal is to help solve that. Of course, as customers modernize their workloads, they continue to adopt managed services, other capabilities on Google Cloud, like GKE, other managed services, that remains a driver. And number 3 is also very critical. As our customers think about reliability constraints, sovereignty requirements, certain performance constraints, multi-cloud networking becomes critical as well. And we'll talk a little bit about some of the innovations we've done in that regard. In this session, we will talk through 4 different use cases. We'll talk about building the cross-cloud network infrastructure for AI. Before you build the agents, before you build your tools, et cetera, what do you need the infrastructure to support, such that your data is close to your accelerators? That's super, super critical. Then we talk about connectivity for managed services. There is no actual standard there, and how we are standardizing that connectivity across different clouds to support cross-cloud interconnect and other things. We'll talk through that with the end-to-end workflow. We'll talk about migration to Google Cloud. As a lot of you know, migration is never a one-step journey. It is a phased journey, and a lot of our customers end up maintaining hybrid multi-cloud estates as they're migrating. And finally, one of the most exciting things, we're going to talk about ultra-low latency for financial exchanges. I think you've probably heard about that in some various other spotlight sessions. This capability only on Google Cloud finally allows financial exchanges to migrate to Google Cloud as well, right? So we'll talk a little bit about that. So without further ado, let's get on to the cross-cloud network infrastructure for AI. I think AI is obviously redefining everything. It's obviously redefining the cloud network as well. AI needs power, no surprise. AI needs accelerators. Now, if you look at this map, this is just representative for the US. A similar map is applicable to the rest of the world as well. But we are going from distributed sources where data centers used to be, potentially more urban centers, to a more widely distributed data center network, right? Where data centers are already all over the place, from urban specific hubs, widely distributed across the globe, right? And that's just the accelerator footprint of the data centers. It's following power. What about the data? Data can still be anywhere. Gigabits, petabytes of data that you have, legacy data, new data that is being collected. The network, today's network, which focuses on specific hubs, doesn't really cut it, right? So we have to redefine the network and what we are doing about that. So if I think about this, amongst other things, in this session, we'll focus on two specific things that we are doing here. Number one, before you build any application, you need data close to your clusters, close to AI, close to GPUs, close to TPUs, et cetera. We're building massive interconnects to support this. We're going to talk a little bit about that. And once you have your data, you need these accelerators are obviously very, very expensive, and you want to make sure that they're not sitting idle. So you need a lossless network at scale, running at scale to support this. So these are some of the things that we are sort of looking to do here. So first is AI native cloud interconnect. This is a grounds-up re-architecture of our interconnect that supports petabit scale capability connectivity to your VPC environment. From on-prem to VPC, from another cloud to VPC, we can now support it. 400 gig, that's table stakes now for this environment. Supports SLA-backed connectivity. One of the other things we've done is we've eliminated the multiple hops to give you flexibility to connect directly where the AI zones are, directly where the AI clusters live. That benefit might not be immediately visible to you, but it helps us in speed of provisioning as customers demand more bandwidth. It helps us in creating more reliable infrastructure because you eliminate multiple pieces in the middle. It helps with performance. And finally, we are launching traffic prioritization with application awareness on this interconnect. So even if you have provisioned bandwidth, you can actually prioritize which traffic, which flow is the super critical for you that we prioritize over this interconnect. Now, whether you are migrating your data or you're using the AI clusters for training and checkpointing back to a durable data source, this is all super critical and very, very important to make sure that the GPU, TPU idle time is reduced. Now, beyond the cost-optimized and reliable access to data, making sure that your clusters are highly performant is super critical. We are doing two things here. First, we are supporting a back-end VPC architecture purpose-built for RDMA lossless communication across the cluster. This makes sure that your cluster remains low latency, GPU to GPU communication can happen. Second, we are building a front-end VPC network that now supports RDMA direct storage to storage sources, parallel file systems like Lustre, that enables that you have high bandwidth access to storage. Finally, I think scale is super critical. So we're investing in both scale-up and scale-out technologies. I won't go into details of that here. There's other sessions that do cover that. But all of that is supported with Google Kubernetes Engine with bare metal instances for a very scalable cluster for your training or inferencing sort of workloads. All right. So we talked about the first use case where we talked mostly about data migration. What about, there are lots of cases where the data gravity challenge remains, and you want to just connect to a managed SaaS, but it still needs access to a legacy application, to a legacy storage source that you might have. So connecting to managed services, a lot of our customers look to do that, has always been a challenge. And why has it been a challenge? There is no blueprint for doing this right, I feel. And we've talked about this in the last few years. Sometimes it's difficult to meet a performance need. A lot of customers rely on internet connectivity, set up VPNs, so managing those VPN tunnels can be tough. Managing that internet connectivity, making sure that that's working to maintain your application experience is tough. There's obviously operational complexity, whether it's redundancy, whether it's security. And there's a lot of DIY work that needs to happen. I mean, how many tunnels do I need? Do I need to upgrade my bandwidth, et cetera? What sort of reliability do I need? How do I maintain does my connectivity across clouds have an SLA? Am I dependent on a third-party provider, et cetera, right? And depending on how large how distributed your data sources and your existing clusters might be, existing compute might be, that becomes a challenge. Obviously, costs, last but not the least here, is obviously super critical as well, right? You don't want to overburden on the cost side such that you run out of your sort of monthly budgets. So I think you've seen this version of this picture before. Cross-cloud network provides an architectural blueprint to do that. There are three things here. Robust connectivity. We're going to talk a little bit more about what we are doing with cross-cloud interconnect in the next few slides. Service-based connectivity. We're going to talk about how Private Service Connect, how far Private Service Connect has come along, and how we are enabling Private Service Connect to be the default for all managed services on Google Cloud. We'll talk about how you can build a scalable VPC architecture with NCC, right? So we'll go through all of these things one by one. So let's first talk about the robust connectivity with cross-cloud interconnect. Now, I think 2 or 3 years ago, we launched CCI for the first time. CCI has been fundamental for customers to build multi-cloud robust applications. A lot of you have used it, and it has had immense success. There was one problem, though. Provisioning of bandwidth always took time because we were reliant on other vendors to support that capacity, right? So a lot of our customers gave us that feedback. So with that, we are working on a collaboration with AWS here. We launched this in preview a few months ago. It's essentially a collaboration that creates an open spec to do multi-cloud right. So the first version of this has been launched with AWS, now in GA as of this week. The few key benefits here are, it is super simple to deploy. On-demand connectivity, and we're going to do a demo later where we'll show this. On-demand connectivity like a cloud API. You call it, it happens. It's resilient and secure by default. So you don't have to say, hey, I want MaxSec. We already have MaxSec for you across the two clouds. You don't have to say, is my connection resilient? we, by default, support the SLA quad redundancy with the 4 nines SLA for you. It has lower TCO versus any alternate solution in the market because it gives you fixed price charges, right? So you have predictable spend with this. Obviously, it's built on an open spec, so anyone can really adopt it, and we're going to talk a little bit more about that. We'll show you this in a demo later, but the configuration steps are really, really easy. It's an east-west API that runs across clouds. You can start the provisioning from either place. Let's say you started in Google Cloud, create a transport in Google Cloud. You complete the handshake in AWS with a key. That just completes the connection. Now later, you can even update the connection. You want to go from a lower bandwidth to a higher bandwidth, you can do that. I really like that GIF here, but sort of walks you through the different steps. Now, we talked about the AWS GA, but we're not going to stop there. The reason to create the open spec was that anyone can adopt it. This is posted on GitHub. So we're expanding this partnership. We'll have upcoming preview with 2 vendors here. CoreWeave is number 1, where we'll support partner CCI with CoreWeave. Use case is very similar. The other one is with Lumen. So we're expanding the use of this API for even last mile connectivity. So with this, what can happen is you want to connect to any on-prem data center. What you needed to do previously was you need to come to us and then buy partner interconnect or something from another provider, which gives you the last mile. Now, as a first-party integration, you'll be able to see where we appeared with a provider like Lumen, and we are announcing an upcoming preview for this capability soon as well. I want to call out that because of the open ecosystem, this becomes really fast. Once we do it once, other providers can just adopt it. All right, let's now see it in action. We're going to demo a smart city safety analyst. Let's see how it's set up. In this real-world scenario, we are really looking at how a smart city built on AI can really improve road safety by analyzing footage of roadside traffic, which it's collecting from various intersections, and provide recommendations to the city planners, to the traffic engineers, to really improve the safety of a city. Now, under the hood here, we are using Gemini Enterprise that runs over Vertex. It's communicating privately over partner CCI. The data is being collected on S3 buckets in AWS, right? And we are using partner CCI real time to fetch those recordings to analyze what really happened. The S3 buckets are months of footage across different city intersections. In this demo, we'll show how Vertex AI can identify a potential issue, potential breach that might have happened here, collects this data and be able to look at that. So it's cross-cloud sort of analytics at its best. And it can make recommendations, right, to a city planner or anything like that. Now, you'll see that the S3 bucket contains video footage that's exposed through a private endpoint here on the left. You'll see that that private endpoint is available on the Google Cloud side. So that's happened over CCI, and we'll show the demo on how this works. On the other direction, on the other side, you'll see that this is all connected through PSC, so we are accessing Vertex through PSC. There's different VPCs here. We are putting it all together using Network Connectivity Center to peer all the VPCs, such that the dynamic routes are propagated wherever they sort of need to go. Now let's jump to the demo to see how we actually build this. So let's first set up CCI. As I said, we can start from any console. We'll start here from the Google Cloud console. You check the connection starting point. We say Google Cloud. You'd look at the transport profile. Here we choose there's a drop-down which tells you which AWS region. US East 1 in AWS mapped to US East 4 for us. We choose that. Then we look at a transport name, any identifier. Here we just call it next 2026 demo. We choose a baseline speed of 1 gigabits. We think that's sufficient as a baseline speed. We choose NCC as your mechanism that sort of puts that together. That essentially just creates the transport. Now, this is communicated east-west to AWS already. It gives me a private key. I take that private key, I copy that over here, and then I go to the AWS console. In the AWS console, I've already set this up so that I paste that private key because that east-west communication has happened, and I accept the connection. You see that the connection got established. I associated with the Direct Connect gateway on the AWS side, hit next here once I associate it with that. And voila, you see that the provider's GCP region US East 1 to US East 4 is automatically sort of created. I accept the interconnect, go back to the GCP Google Cloud Console. You see that the connection is active. I just verify everything's working fine, 1 gigabits, IPv4, US East 4 to US East 1. Look at those route tables on NCC. It shows you that those private endpoints that I talked to you about in the setup, the 10.100 subnet, is available for us. I look at the AWS console, the 192.168 subnet, which is on the Google side, is available. So this communication is really happening over the private IP space. All right, now we set this up. Let's see how we can sort of actually put this to good use now. In this demo, we're going to analyze a pedestrian and a taxi incident in a New York City crossing. Not suggesting that that's dangerous in any way, but nevertheless. All right, let's do this. So hit play here, the demo starts. So I have my application built out. I enter the prompt that we receive a non-emergency 311 complaint from a near miss accident that happened on an intersection in New York City at 3:15 p.m. So I enter the prompt. I do a video catalog search. It knows that it needs to go to AWS to fetch that video. It looks at S3. I really like this thing here. Notice what it did? It realizes it's going to fetch a video, so it flexed the partner CCI bandwidth to 5 gigabits. And look at 4.97. In real time, it was able to fetch that video at the 4.97 Gbps, look at that video, and identified the actual footage that probably caused this to happen. Right? You see that pedestrian near-miss collision that potentially happened. The pedestrian might have complained about that to the city people. And the AI gets to work. It identifies it. It puts together a full incident report for the folks that work in the city here. Right? Like, hey, this is what happened, this intersection. It doesn't just do that. It actually goes and then files a complaint against the taxi. It looks at the number plate of the taxi, so files a complaint against the taxi. Then it suggests some near-term actions. It also goes and it files a ticket to look at this intersection, past videos. Is it really dangerous? Is it not? Is it a one-time? Is it not? So it sort of looks at all that to sort of set that all up for me, and then files the incident report. As simple as that. Right? I think Nick here built the demo, so thanks for Nick for being here. So you can talk to him about it, and he can give you more details than I could. So thanks a lot. A great demo, I think. All right. So now we talked about cross-cloud network providing an architectural blueprint. We talked about the CCI connectivity. That's, I think, awesome. Now we're going to talk about service connectivity with Private Service Connect. So Private Service Connect, we've talked about it before, is the default for managed services in Google Cloud. Whether that is Google managed services, whether that's partner managed services, PSC is growing for adoption even with customers' own services, right? We see growth in all three use cases. And we are investing in few areas, right? And we see the third use case will continue to grow as customers build more tools and services over MCP. Right? A lot of Google services are being exposed at MCP tools, so we think that this use case will continue to grow. So we'll have three areas, really, based on feedback that we've received from customers over the years. Number one, automation. As developers build applications, now we are jumping from the robust connectivity layer to the service connectivity layer. So a little bit of a transition, but developers don't want to set up that network. Developers want to access services when they want. You saw that example of the smart city. They wanted to access that service sitting in S3. Doesn't matter where they are. So simplified PSC setup where you can create the endpoints at scale is super critical, right? Without friction there. So we're going to continue to invest there. Scale is important. We'll have many service attachments, many endpoints, et cetera. So making sure that our network architecture can really, really support that scale easily is super critical. And security, right? When you expose access from one service to another, you want to make sure that you are actually allowed to access that service, right? So the governance is very important. Access control is super critical. So we're going to continue to invest in those three areas. So let's just talk about what we have done over the last year and a half in these areas and talk to you a little bit about that. So with automation, we've introduced a service connection policy on the PSC. The service connection policy takes away the onus from the network administrator to approve every PSC connection. The network admin can delegate the provisioning to the service admin, right, who actually wants to set up the PSC connection. So the network admin can say, hey, for this service, this VPC network is allowed to sort of access that. Once they say that in that service connection policy, when a customer comes in, when a service admin comes and creates that PSC endpoint, it's already, with the pre-approved delegation, the ePSC endpoint can be easily created. I think this is being put to good use by a lot of our customers already. We have continued to expand all the services that support it, and we have many more that are available today. So definitely encourage you, if not tried it out, definitely encourage you to try this. Now we talked about how we can make the creation of the endpoint simple. We are making a number of innovations on the scale side. PSC propagation for NCC, Network Connectivity Center, is a key feature here. Whether it's the PSC endpoints or the PSC endpoints for Google APIs, now can be propagated with the across the VPCs peered across NCC. You can create an NCC policy that allows to propagate those PSC endpoints wherever you might need them. It's backward compatible for new and existing deployments. So that's one thing that we have done. Second is we're continuing to add scale capabilities, whether it's fan-out scale, fan-in scale. In this case, we are expanding the number of connections that a PSC endpoint can handle. Like, I think this was a feature that a lot of customers did ask us for, and I think that's going to be available soon later this year, where we'll support more than 100,000 simultaneous TCP connections. And we are working with all the different producers, Cloud SQL, Memory Store, to make sure that on their side this is also supported. All right, we talked about scale, we talked about automation. What about security? This is a great feature we added for producer-side authorizations. In this case, you see two PSC endpoints, one/foo, one/bar, and my policy allows /foo to access this service attachment. Note they're on the same VPC. /bar, I say deny. So based on identification of that PSC endpoint, now I'm able to say, hey, this endpoint is rejected from accepting a connection. This endpoint is authorized for a connection. So I think this is a feature that a lot of our customers are using. And finally, if you need layer 7 inspection for NG firewall, we have integrated with a load balancer that can be put behind a PSC, and firewall can be attached to a load balancer. This allows for any sort of L7 threat inspection and other things. All right. We talked about managed services. PSC for now customer managed services. A lot of our customers are building their own managed services using various environments, GKE, Cloud Run, Service Mesh, etc. We have integrated PSC workflows into those environments on both GKE and Cloud Run, such that now you can expose your service. Your development team, your application team builds their service. Now you can expose it using PSC. For end-to-end automation, we are integrating with service bindings on load balancers, such that you have an end-to-end capabilities. You don't have to sort of do things manually to connect different negs and different other capabilities to the service. And we are also integrating this with App Hub and App Registry. You'll hear a lot about that in some other sessions, where these applications can be exposed to the App Hub console, etc. All of that such that if you're building your own services, your dev teams are looking at that, they can easily do that. I love this case study with Databricks. They are building a multi-tenant SaaS architecture. We thank them for their support here and partnership there, as we collaborated with them on a number of features, like whether it's Private Service Connect, Network Connectivity Center, VPC-SC to deliver a serverless platform on Google Cloud, leveraging some of these capabilities. And there's a highlight from one of their engineers, Mahesh. Thank him for his support here. Another one which I love is the MongoDB case study, and you'll hear a little bit more from Nate on this. They have a special protocol on MongoDB on how you need to access. There was a single IP on one side that could not be migrated. So we built this feature called port mapping, that without having to rekey any IP addresses, you could access PSC using a port mapping feature. Again, helps with IP efficiency, scalability, faster deployment, and sort of management. Finally, PSC adoption has grown. We continue to add more and more service to Private Service Connect, and the ecosystem continues to grow. Again, thank you for your support, and over to Nate.
Good morning, everybody. Oh, that's a good response. I love that. So, hey, my name is Nate Wood. I am the Senior Director of Cloud Network Delivery at Ford Motor Company, and I want to take you through some of our journey with Google Cloud from when we first migrated to our adoption of NCC and other constructs that we use day to day to connect all of our vehicles, manufacturing systems, corporate environments, whole 9 yards. You guys ready? Yeah? Just make sure everyone's awake. All right. So a lot of exciting things happening in the world of GCP networking. And I'm lucky enough to be able to work with Google on some of those things and lead a group of very talented engineers and engineering leaders at Ford. Our scale is massive, so we appreciate things that can scale with us and make it simple. So I use this slide frequently because as infrastructure and network engineers, we try to take the complex and the complicated and make it easier for our end users. When we focus on simplifying all of our architectures so that the network isn't something other teams have to worry about, it helps to increase adoption of the things that we bring forward. The next slide that I have coming up, for any of you that are network professionals, do not gasp. Just brace for impact, okay? That was our network at one point. And it seems a little bit scary, but I think it follows a lot of patterns that customers have when they first get into Google Cloud or they're doing migrations. Our journey was typical. We had to meet business commitments, so design decisions were taken into account to be able to enable speed and availability of services for our downstream application teams and development groups, because they just needed the network to work, right? Naturally, because of scale and quota limitations, we went back to stitching together different VPCs through VPN constructs because that was familiar and it gave us a way to get around some of those limitations that we were running into. Obviously, over time, there's better ways to do things. We wanted to avoid having IPsec overhead and get closer and closer to the foundational layer of Andromeda networking and get it closer to our customers that are using it. Although IPsec overhead can be minimal for a single flow, when you're talking about billions of flows, it has a massive multiplicative effect. So, where are we today? We're here. A little bit better than that bowl of spaghetti, right? Yes? No? Maybe? Yeah, I got a thumbs up. I love the thumbs up. That's great. So last year, we worked with Google to migrate to NCC. It was a long-standing goal because we knew that NCC was a proverbial horse that we were going to hitch our cart to, given all the development and focus efforts that are happening with that product in GCP. As we were working through that, something that I'd recommend for anyone who hasn't gone through NCC adoption yet, make sure that you take the time to focus on a staged migration. Look at your quotas, all of them. Every single quota in your environment before you move. If you have lower environments, tackle those first, because then you can start learning how things will look when you get into your production workloads. With the continued development of different service offerings and best-of-breed technology leaders, we think that combining that and the future capabilities of NCC allows us to have future-proof networking in GCP. We went from organized and understood complexity to simplified flows with NCC. This is probably one of my favorite slides. I've used part of this graph internally because the immediate benefit that we had as an organization, internal network construct or Google construct to construct connectivity, we saw anywhere from a 20 to 90% reduction in latency. No application refactoring, no waking up developers to change their code base. The network enabled that. I think that's pretty cool. I hope you guys do too. All right? Oh, I hear a clap. We like claps. Yeah. So that graph there where you see the fall off, that is quite literally when we accepted the spokes on NCC and moved traffic away from our VPN tunnels. This, as I mentioned earlier, was because of the future proofing by getting closer to the Andromeda controllers that are inherent to Google's SDN networking platform. By cutting out VPN, we're closer to the data plane, and we're working more directly with the software switch as opposed to CPU-intensive processing on the network. In a previous section that Himanshu touched on, we looked at MongoDB. We are a MongoDB user or customer, partner with them. And given our scale, at one point, we would have to have upwards of 150 PSCs per Mongo cluster. That's a lot. That's a lot. When they worked with us, and we were early adopters of the port mapping for PSC connectivity, we went from 150 per cluster to 3. A little bit simpler, right? I mean, who wakes up in the morning and says, I want 150 PSCs all over the place as opposed to 3? Nobody. See, I knew it. I knew it. So as we're combining NCC and PSC, that enables us for future networking adoption, especially in the realm of AI. I'm sure we all have heard about AI here at the conference over the past few days. As we continue to lean more in with our Google partners and the engineering groups there, that gets us closer and closer to be able to deploy these things in a safe and scalable manner by connecting Vertex through PSC and continuing to lean further and further into the future offerings that NCC has. I will be here afterwards, so will a couple of the engineers from my team. So if you have any questions, I'm here to talk and help in any way I can. Thanks for your time. Mahesh, up to you.
Thanks a lot, Nate. Good morning, everybody. My name is Mahesh Narayanan, and I work on VPC networking in Google Cloud. In this section, we'll focus on migration to Google Cloud. We talked about in the previous sections about connecting cross-cloud and connecting to SaaS applications. But a fundamental journey for many organizations is modernizing their infra by moving to Google Cloud. In this segment, we'll highlight how networking facilitates a smooth and efficient migration process. Let's look at the primary drivers. The primary drivers for migrating to Google Cloud often center around infra modernization and consumption of Google managed services. Customers aim to seamlessly move their VMs, databases, and applications from on-prem data centers to Google Cloud. What is critical to a successful migration are several networking considerations. Number one, building a highly scalable, future-proof network. Maintaining a centralized IPAM to reduce IP conflicts. Ensuring minimal to no downtime during the transition. And achieving comprehensive cross-environment observability. Google Cloud directly addresses these needs through 4 features. Number one, Network Connectivity Center, or NCC, for a scalable VPC design. Number two, the new Cloud Number Registry, or CNR, for streamlining IPAM. Number three, the new Hybrid Subnets feature for IP preservation for VM migration. And last but not the least, new Cloud Network Insights, or CNI, for end-to-end observability. Let's talk about each of these networking innovations. Let's start off with Network Connectivity Center, or NCC. This is our powerful solution designed to simplify and dramatically scale your VPC network. Let's talk about the 3 value propositions. Number one, simplicity and scale. NCC provides a centralized hub-and-spoke architecture that helps you model an easier network management. It drastically increases your VPC scale to 250 spokes, a 10-time increase over what VPC peering can do. Advanced networking. NCC offers sophisticated features like transitive connectivity to PSC and PSA services, enabling secure access at scale from any connected spokes. It also delivers granular routing functionalities through inter-VPC NAT, route filtering, and even IPv6 subnet support. Global use case. So NCC is designed for diverse global networking needs, including site-to-site WAN connectivity through SD-WAN support and even Cloud VPN support. It provides robust cloud interconnect deployments. With these capabilities, it facilitates a complete cross-cloud network architecture, including scalable VPCs to run your AI/ML training workloads. In essence, NCC simplifies complex network topologies, providing unprecedented scale, and offers advanced controls, making it a cornerstone for large-scale enterprise deployments. I'll quickly touch upon three areas of innovation for NCC, that we recently launched. Number one, security insertion. So we launched ILBS Nextstop, with which you can deploy a secure web proxy in transparent mode, or even a custom network virtual appliance for your security needs. For mitigating IP exhaustion, we now support privately used PUPY IPs and dual stack and even IPv6 subnet with filtering. And we are expanding the ecosystem. Himanshu talked about cross-cloud interconnect, partner CCI. We support that through NCC, and even addition of new producer types like Google Cloud NetApp Volume for storage services. Let's move to IPAM. A major challenge in large-scale migrations and cloud operations is having an efficient IPAM. The network engineers dole out lots of IPs. The IP addresses are discontiguous. They are fragmented. GKE, because of its nature, uses a lot of IPs. And everything is being used or maintained through outdated spreadsheets or custom scripts. This is not scalable. To solve this, we are excited to introduce the new Cloud Number Registry feature. CNR acts as a centralized brain for your organization's IPAM, providing automated discovery and making IP management much easier and scalable. Let's look at some of the capabilities of CNR. Number one, it features automated discovery mechanism, automatically cataloging all compute engine IP resources. Number two, you can gain clear utilization visibility across your entire org. There is an IP search feature that allows flexible queries based on metadata. And for IP planning, it works across the entire org, meaning if you have multiple projects, it works across all these projects to give you a centralized view. And lastly, we are also, for cross-cloud use cases, even for on-prem use cases, where we have integrated with third-party providers like Infoblox. I want to touch upon Infoblox partnership a bit more. So it builds upon Cloud CNR that I was talking about. This integration provides significant benefits. It reduces operational risk and from IP conflicts and accelerates cloud provisioning. There's a quote from Matt Landry, thank you for his support, which notes that with this feature, with this partnership, customers now have greater visibility and control and simplification of networking and security. To truly revolutionize IPAM, what we've also done is introduce this functionality within the network domain agent. If you were in some of the networking sessions yesterday, we were talking about the networking domain agent and the different use cases. The NDA, or the network domain agent, uses CNR and other IPAM APIs in the backend. It also uses metrics and logs, collects it all together, and provides a comprehensive IPAM analysis. It allows network admins to use natural language to perform complex tasks, like show me what IPs are being used by my load balancer in a particular region. What is the subnet utilization for this particular subnet? Can I use it in GKE? Or who is using which particular IP and at what time for IP forensics? By turning complex queries into simple conversations, the agent provides actionable insights, moving IPAM from manual toil to automated intelligence. All right, let's talk about migrating VMs from your on-prem to Google Cloud, right? Another significant hurdle is in enterprise cloud migration is preserving the IP addresses and assignments, right? And why is that a hurdle? Because many legacy applications have hard-coded IPs in their configurations, in databases, and sometimes even in the binary. If you don't do it right, if the IPs are not migrated, the application can go down, and the business can be impacted. This concern is the very reason why some of the migrations don't even start. While solutions from VMware like vMotion address this on-premises, Cloud migrations haven't had a comparable answer until now. The new hybrid subnet feature is designed to provide low-friction, fast cloud migration by allowing the IP schema preservation. Let's see how it works. It works due to the magic of our SDN stack. As some of you may know, it's called Andromeda. The migrating, I'll go a bit about the different components when you set it up. But on the left side, you have the on-prem, and on the right-hand side, you have GCP's VPC network. The VMs are part of subnet 1058.240/22. You create a similar subnet on GCP. We call it a hybrid subnet resource, right? The migrated subnet is configured and advertised on both the environments, right? When a traffic is destined to the hybrid subnet from GCP, Andromeda first checks whether there is an endpoint in GCP that can respond to it. If nothing is programmed, if you have not created a VM, it then resorts to normal routing and sends the traffic to on-premises. If it does find a resource, which is after migration, then it sends the traffic locally onto the GCP where your VM is. With this approach, the benefits are we use standard protocols, so there is no new training for the network engineers. There is no performance overhead because we're not using L2 encapsulation, no MTU changes, standard L3 routing. And lastly, since the IPs are not being remapped, this reduces your migration risk. All right, let's move to our favorite topic, observability. As we embrace AI and agentic architecture across clouds, it's becoming pretty complex, right? Applications are now deployed across multiple clouds, on-premises, and rely on various SaaS services and internet endpoints. The advent of AI means that the number of agents and the data, and the data volume are exploding. Workloads often straddle AI inference endpoints, applications, and data stores across different environments. While we have good visibility within cloud, we realize there is a critical need for a comprehensive visibility across the cross-cloud network. So we're excited to announce Cloud Network Insights for network observability. It reduces the mean time to detect and mitigate network issues. It provides things like network performance monitoring, digital experience monitoring for agents, web application, and APIs. It supports agentic protocols like MCP and agent-to-agent protocol. It is enabled through our partners Broadcom's AppNeta technology. A user can use natural language queries to interact with and get useful insights, just like with Network Domain Agent. So if you're a customer who has cross-environment observability blind spot, please use CNI. All right. So we saw the drivers and features for mainstream use cases for migrating to Google Cloud. Now, let's look at a niche vertical of financial exchange and see what solutions we came up with over there for their cloud migration, right? So we have built a purpose-built infrastructure for our financial services market. It's built on an ultra-low latency solution, which is fully managed and designed specifically for the most demanding financial market requirements. Like to highlight two pillars as part of this solution. One is the compliance, which is table stake. Adhering to regulatory standards is the only way to ensure market integrity in this market. To support this, we have built tools like packet mirroring, monitoring, logging. In financial services, time is measured in 9 nanoseconds, and all these tools work at nanosecond granularity. Number two, determinism. We guarantee this through high-precision clock, which serves guaranteed jitter and variance for all transactions. This design achieves three primary goals. It ensures fairness, it provides openness and elasticity for anybody to enter, and improves market liquidity. And number three, along with our AI infrastructure, it provides an opportunity for the financial services to drive true innovation across the entire stack. To close this all, these are the key takeaways that I'd like to recap. We have built an AI ecosystem that caters to your different needs. This is evident through the different keynotes, different sessions. Agents and data volumes are exploding. The workloads are straddling different environments. Networking is more important than ever in this agentic era. And Google's cross-cloud network delivers the networking fabric for this agentic era. Thank you so much.